Hey everybody, it's nice to be back. As Marie mentioned, it has been some years, and it's always a pleasure to get back to Namur. My background is design, interaction design. It's really hard to see you guys. Yeah, you're there. Then machine learning and then robotics, and I combine that with fashion. So I create wearable electronics, and I do all kinds of fun stuff around the body. Partially, I work on my own work, which I will show you today. Partially, I work with companies for integration of like sensors and all kinds of electronics in fabrics, for example, or like product design, like brain-computer interfaces. And then my other 1/3 of my time I spent on education, and especially getting more females, more girls into technology, because we are in 2024 and it's still kind of a big problem. There's not too many females in technology still. It's not a 50-50, and especially we need much more role models to get more females into technology as well. So me and a lot of my sort of collaborators are trying to actively do that. My name is Anouk Wipprecht. You can find me online. And I'm going to tell a little bit about my work, what I've been doing the last 22 years. I started when computers were pretty big. So I always said, like, the designs that I created looked very sexy from the front, but you turned around and there were these big computers on the back of these models, and then the wearers and myself, sort of. And technology came a great end, sort of. We are able to integrate really small pieces of electronics currently in fabrics and into design, so that is really really much fun. I do things I use things like sensors. I sense the surroundings, so I'm going to tell you a little bit about that. I also sense the body itself, because the body itself has a lot of data points as well, of course. So when you're looking at the spaces that we have around us, one space for me is really interesting, is the personal space. You can see here the intimate space, personal space, social space, and public space. And these are spaces that we have all around us. And it's up to us to invite people into these spaces. And sometimes, people force themselves into these spaces. And from a fashion perspective, that's quite interesting to me. So you guys are all in my public space. I hope later on in my social distance or in my personal space as well. But these kind of this theory of proxemics comes from this guy called Edward T. Hall in the 60s. He started to notice that different people have different personal spaces, and he started to measure that with a physical stick, a wooden stick. So he was going up to people to see what these spaces were. And for me, that's quite interesting. So I took basically his measurements, and instead of using a stick from one person to the other, of course, we have things like proximity sensors. So you can sense using ultrasound or the ultrasonic rangefinders that I'm using. I can measure all these spaces. So some of my designs that do the measurement of the spaces around us, they have integrated sensors that do so. So one of my dresses is this dress. It was a prototype in 2010 for a robotics exhibition in Prague, and in 2015 I had the opportunity to work this dress out when I was working at Intel, the semiconductor company. And it has 2 sensors in the black parts in the dress, and they measure up to 25 feet, which is 8 meters, I believe. And when you step into the personal space, this dress is also based with mechanics. So when you step into the personal space, this dress is literally attacking. It's very handy. So there's mechanics and servo motors in this dress on the shoulder plates, and I programmed something that I call 12 states of behavior, because if this dress is just like mounting out and in, it's kind of not super interesting, because it's very predictive. So depending on how and how fast and where you're standing in this space, this dress is reacting differently to each person, basically. Sometimes I like to hide all my electronics. Sometimes I like to show them. In this case, I really want to show all the the sensors, all the cables, everything where the wires go, and all of that stuff. So you can see that here. So it looks like very, kind of very creepy almost. And that was. That was the spider dress. It's for me really an important design because from kind of predictive things and machine learning, there's a lot in that. It's like one of my most intelligent designs in regards to sensing as well. Another dress that I created was in 2011. I started it in 2010 with a collaborator of mine, Nicolo Casas. And both we were exploring what we could do with the use of big 3D printers. It was the time that for the first time we could selective laser sinter. So basically, let me see if I can do this. Yeah, so this whole part from here to down here, we could print fully. At one point you could print bigger things. So for us it was an opportunity to see if we could print full dresses out of that sort of. This dress has the notion of another animal, the octopus or the inkfish. We call that in the Netherlands where I'm from. And this animal pushes out ink and it can escape. And that's also a little bit with a smoke dress. You step into the personal space. Again, it uses ultrasonic rangefinders. But instead of a point-to-point, what I see is kind of a cone in data. It measures the amount of people that are in the direct environment of this dress. And the more people, the more it starts to smoke. So I'm using the same sensors, the same kind of the data, but I'm using the data differently. So that is the smoke dress. In this case, to get the smoke really organically out of there, there's this space built in. So the smoke comes from here, it's a little system on the back, goes around and is being pushed out through these grooves, sort of creating a pretty cool effect. And this was selective laser sintering process. Again, this was a long time ago, but it was the first time that we could do that. So we could also 3D print in TPU, which is a thermoplastic polyurethane, which allowed for designs, complicated designs and geometries to be still flexible and also kind of rubber-like. So this was the dress in my studio. I'm using, it's a system with a hot nozzle, and I'm using different kinds of fluids depending on the space that can kind of push it down a little bit or push it up. So I mostly take a sample of the space that I need to present this in. This was for an sort of gallery pop-up kind of thing. And then I decide on which one to use. Another of my dresses is a dress that makes cocktails. It's a cocktail dress, but a real one. So it uses a peristaltic pump. It's kind of a cool company. I think it's still around. It's called Party Robotics. It's an open source kind of company. And basically, she pushes on a button. The peristaltic pump is turning around and is pushing the fluid from one part to the other. And that always makes a great thing at parties and at events as well. So here you can see the peristaltic pump in the back piece. So the back piece is in the back. It also has the battery in there, little push button, and everything is integrated. And I created those dresses for Cirque Du Soleil, which we know from the theater, but they also do a lot of kind of fashion experiences, and they had a restaurant in Ibiza, and I told them that it would be fun to create some kind of walking food experiences. So this dress was really kind of cool. It made drinks. I also had a dress that had gumballs on the shoulders, and it shot gumballs, and that sounded like a good idea, but in fact it shot gumballs at people at one point. So that design got too hostile, so it got archived. But I still, the mechanism of it was really, really cool. It was pretty significant, but this dress series stayed. We also made them later for boys, so boys and girls were walking around, and they were in different kinds of colors. So what I'm trying to do and what I'm trying to figure out is if and when we put technology on the body, what does it do other than just blinking and bleeping, sort of? How can you build in some kind of learning system? How can it get to know you, for example, how can it become more social and playful, like the cocktail dress? How can it become more defensive and behavioral, like the spider dress? Or how can it become more expressive and sensitive, like the smoke dress? So really seeing fashion as an interface. So social interface, a playful interface, and also an emotional interface. I do a lot of collaborations, so that can be tech firms, that can be like the fashion industry, for example. Research things, and yeah, so I work a lot with both companies as also like fellow collaborators, designers, architects, and that's always really fun. Sometimes I like to do a project by myself, another then I get kind of lonely in that project because you're just doing it by yourself. Then the next one I might like collaborate with people and all. So it's really fun for me, and I travel around sort of the whole world. In 2016, Audi was asking me to make a collection based on one of their cars, the Audi A4. So I ripped out their parking sensors and their LED matrix lights, and I made that into these dresses that like were blasting out light. And there was kind of a funny concept. They thought I would not take it that literal, but it kind of worked out sort of. So the LED matrix lamps, they came out of the dresses, which was kind of a cool thing. I also had a dress, I don't have it here, but it was like mechanized. It was moving as well, which was a fun one, but a hard one to carry around sort of. And the other thing what you can think about is, with my field, FashionTech, is that you can also think of like the integration of things in the body, or also working with the physical body, like your arms and legs. And I had the opportunity to work with this lady. Her name is Victoria Modesta. And she's a bionic pop artist, and she's super fucking awesome. She lost her leg like early on in life, and because she had problems with it, with her feet and with her leg. And at one point she said like, okay, let's just cut off my leg and deal with it. That way it would be less of a burden. And she has been wearing prosthetic legs ever since. And the one thing that she didn't want to do is wear a leg that looks like a normal leg. She wanted to basically, not hide it. She wanted to show it. And she wanted to create this new kind of, being bionic. And that is what she has been doing ever since. And I met her in 2014. And we had a flow. And I've been designing, several legs with her. And it has been really fun, because for me, normally I need to integrate electronics on the body. And now I can basically use her leg and stash it full with electronics from that side. So it was kind of a win-win situation for us both. So we created this leg, a smoke leg based on the smoke dress. So she steps in it, it starts to smoke. For Art Miami, we created a piece with Eric Goldenberg. He created 3D printed instruments, which you could also see behind. But her leg had an accelerometer, so she could push in music and sonify that. And using the tusks as well to create music with it. And we performed that at different locations during Art Miami. And also a current and a recent collaboration that I did with her with a screen dress. This was for a show for her for Crazy Horse, in where, and you cannot really see it too much. This has a spinning element and kind of a LED shining in it, and it shines all out. These were designed with e-panels in there. And I think I'm going to skip this one because it's going to play the full. It's going to play the full video, which is going to be a problem later. There's all these kinds of different legs basically that we created together, and also this project for Rolls-Royce, and that's a very special project to me because I had the opportunity to create a leg using a really small Tesla coil that is embedded in the heel of this shoe. And it throws out a Jacob's ladder effect. So I'm gonna see if this is gonna play from the. So, in my video as well. Okay. I had a little hiccup. That video should have played from the half of it, not fully, but it's either way a fucking awesome video, so there you go. So, but I wanted to show you some of the, it looks all smooth and there's like a bunch of CGI that they pulled over that. It was an all-female team. The director was Jora Francis, which is really cool. If you want to look her up, she does a lot of like clips for like Beyonce and all of that stuff. So it looked really sleek, but I wanted to show you also a little bit like what is behind that. Because when you're prototyping, basically it looks like shit, it looks like that. You're just doing like some tests to see how small you can get things, how things can look, what you're working with, the shape of things sort of, so that you're gonna see here. You're gonna see here in the right corner basically the base of the shoe with a pretty big heat sink in here. The board is in there, goes up to the coil. The coil basically goes here to this part, which I'm controlling. And that shoots a little, a piece of electricity between it, which is called a Jacob's ladder effect. And this part you can kind of control, sort of. So, yeah. Ready. So that is basically being repeated to up. And then I seem to have some problems in my videos. So here you can see that you can control that ladder going up basically. So one of the things that you need to think of with a leg, your full body needs to like be on it, sort of, you know, and it carries all the weight of your body, and also like the way you walk and your gait and all of that stuff. So the cool thing about this leg is that Victoria was only standing on this part and on this part, because basically what I wanted to do is use this whole inner part like a sort of as a void space where the bone normally is, to make this effect happen. So this needed to be really, really strong and really enforced for the structural integrity. And she was also wearing a body, so I don't know if you saw that as well, which was also like a 3D printed, and it had like some of the artifacts of the car on there. So that was one of the projects in where you really need to see how small you can go, sort of. And then I had another challenge, because in the end, this leg was there, sort of, you know, and Victoria always likes to have one leg a little bit thinner than the other, just for visual, sort of. And it was kind of at its limit. And then she said, like, oh yeah, my ankle needs to be slightly a few millimeters more thin. So then we needed to like redo this whole process again, sort of. But it's also really really, really interesting, of course, to make things as small and as elegant as possible as well. But yeah, there's a lot of like redesign and recreation and going back and forth when you're designing this kind of stuff. The next topic is body signals. So there's a lot of interesting things, of course, that we can measure around the body. You can think of EEG, so brain signals, EMG, so muscle control, sort of, which can be measured here a lot. EDA, galvanic skin response for fight or flight. If you're measuring anything like that, respiration. It's interesting for like kind of emotional data, the way we use our lungs, the way we breathe, for example. You can get a lot of emotional data out of there. Heart rate variables, so the volume and the rate, temperature, oxygen. So there's a lot of like cool things that you can pull from the body, and also accelerometers, which I talked about before, the place in space of your body parts. One thing that clients often come to me for, they say like, yeah, it would be really cool to get kind of a design that is reacting on your emotions. And now that sounds really, really cute, and I do agree with that, sort of. But it's also very frightening because we are often like not in control of like little things when you are having like chicken skin, or when you're blushing, sort of. That's sometimes a thing that you do not really want to lose control over for like multiple reasons. So in order to like kind of test that out, I created a project called the Heartbeat Dress, in where it shows your heartbeat, and that again sounds very nice, but if it's actually happening, if you're really showing your heartbeat, it's kind of for everybody to see, and it also makes you like really, really weirdly aware. And I do that sometimes, that I wear this dress or the collar piece on stage, and then I put it on, and people think that I have my shit together, right? That I'm being all cool here on stage, and then I put the design on, and it goes, your heartbeat goes like so many miles a minute, and it's a really frightening experience as well. Because we're not really kind of ready ourselves to show that side of ourselves. Because we post, for example, and we post on social media or anywhere else when we're happy. But we often don't do that when we're having other like emotions, like depression, or when you're afraid or something like that. So we tend to basically propagate happy feelings and not sad feelings. Well, if you do have a design that is basically like showing you and your full self, those things are also, of course, there. So that's always an interesting thing that I always think about. To really show your pure self, you really need to show all of your. So that's this project is the Heartbeat Dress, which goes with that thought. This was at Swarovski headquarters. So that became, one of the smallest. I already showed you the one with the Tesla coil, but this became the smallest kind of piece of electronics that I ever worked on, because it didn't only stash all the electronics, it was also doing the measurement of heartbeat from a frontal area, which was kind of our like little research in there. But the piece could be worn like as a necklace, and you could also insert it in the dress, and then the whole dress kind of lighted up, which was kind of a cool thing. So that was what I did at a residency at Swarovski, which is a crystal maker, and the idea was to make their crystals basically smart. And then I added the extra like research for myself on the heartbeat and the showing of the heartbeat. So here you can see the little PCBs, and the crystal itself is also like touch sensitive, which was kind of cute. Then in regards to brain signals, I did a few things. When I was working at Intel, I created this dress. It's the synapse dress. It was the notion of that we could follow somebody and see how while interacting with people at sort of an event, what that did to the body, and what kind of stress was being put on the body. So there was a little camera in the front, could see what was happening. There were proximity sensors, and it was also measuring her heart rate and also her brain signals. So that was what I was doing when I was working at Intel, the new devices group. I made a lot of weird shit there. And that was fun. But so this dress was one thing. That was the first time that I worked with brain signals, because I could not make my own device at that time. That was 2014. I hacked an Neurosky. You can also find that online on Instructables, which I will tell a little bit later about. So I basically hacked a commercial device, and I put that into my own headset, because I thought that looked kind of cooler. The bad thing about the Neurosky at that time was that it was a 1 point, and it was doing it from the frontal area. If you're measuring brain signals, that's a little bit hard, because there's a lot of movement, which is more dominant in your data, what you get back. So that became a little bit of a problem. So in the next project, I started to collaborate with a company called KIKK, and we ended up making our own BCI. At that time, there was only the commercial devices that were not really working for me in regarding to the data that I got out of it. And you had like medical systems, so it's called the 1020 system with 64 electrodes, and it's kind of a big thing. So when I was working at Ars Electronica as an artist in residency, I proposed to create sort of a BCI in that case for children with ADHD to measure their focus. And when the focus was high, there was a little camera on the head which would go on to see what was happening in their surroundings and kind of to feed that back to them, which was a project that was funded by the EU Commission. And that was really fun for me, because I could play around instead of working on a commercial job. Most of my projects, like the Audi collection, are between 6 weeks to 8 weeks for multiple dresses, technology, embedding, coding, programming, a lot of soldering and all of that stuff. And I had a little bit more time for this project, so that was really cool. So what I wanted to tackle was working with children, but not using this 1020 system of 64 electrodes on the head, because it's a lot. The children are being measured in a white room with a doctor, which for us researching the data is not a playful experience. So the stuff that we get out of it was not quite sort of playful and pure. So I was doing a little bit of research, and this is what I came about. It's the P3 wave of the event-related potential, and you don't have to, you don't have to remember this, but it made this like really good, like mohawk kind of shape. It's these electrodes on the kind of on the back of the head, and then here, and then the reference point, sort of. So that made for kind of a cool design, and I could also create a little camera that would be in the front of the headpiece. And this was a little prototype. And yeah, from that prototype, I started to look at like what kind of things. These are active dry electrodes, which I used in there. They didn't need the Salina, so you didn't need the kind of the gooey stuff in your hair. There was also one with a kind of a 3D camera embedded. So that became an whole thing, and yeah, when I'm prototyping with it, it looks messy. When it's all built in, it looks like super sleek, sort of. And because it was pretty successful, we actually worked it out into a product. So this is a BCI. It's 8 channels, and it has its own its own full set. And we are using it for like, yeah, a lot of research. It's kind of easier accessible than like the whole medical system, but it's really reliable, and the resolution is also really, really, really good. So you can, yeah, read a little bit about this later on. We also do sort of an hackathon, and this is basically happening every year, and also a spring school. And this is an old slide here, but it happens every April. So if you're interested in EEG and BCIs and all of that stuff, definitely check into that. Another product that I did, because the other one was 8 electrodes, was with the same company, with KIKK, and also a school in Austria, and we created we call it a pangolin grid. Instead of using 8 channels, it used 1024 channels, which is like a really, really good resolution if any of you have done anything with brain signals. Neuralink from Elon Musk uses 3700 channels, but kind of that's more an invasive technology. Whether I rather work on non-invasive technology, so things that you can put on your head, but you can also take them off, rather than it's necessarily built in, other than for things like stroke rehabilitation. So this is the pangolin system. And we created an address with it that basically uses any of those 1024 channels and creates movement or creates light. So you could see, while you're looking at the dress, you could see like basically all these brain signals coming in and out. So that was kind of cool. The bad thing about this was that you need a shaved head for it. And I put on my, I think my Facebook, that I needed a model, and that is going to be hard because the model needs to be having no hair, sort of, and I actually got a lot of replies. So I worked with Daliette in America, and KIKK worked with Mac in Austria, because it was COVID, and we did this whole project like digitally and all of that stuff. So that was pretty cool. So the last project that I'm going to present is a more recent project, which also works with brain signals. It works with the workloads. It has little pupils, and I think it's a really cute dress, and I love googly eyes, so I always want to do this. These are hyperpixel screens. They're touch sensitive, and they're round, which lends itself really good to put kind of in a dress. And the more workload is being detected, the bigger these pupils get, and the less workload, the less. So you can see basically the stress level while looking at this dress. So the bigger the pupils, the more stress there is. And you can see that. You can see that here. We're doing a little test basically for the system to recognize. We call this a spell check. So basically use machine learning to see and to dedicate some of the interactions within the dress, in between your brain signals and the dress, and then sort of the interaction can start. And here I'm asking my friends to think of a cute dog, and you can see the dress react to that. Think of a cute dog. That was the first time that we tested. But the latency, there's a little bit of latency, but it's pretty cool. And I really like this dress for the sort of the cutesy factor. And it's also really fun to see the stress level being translated like that. While prototyping these designs, prototyping is a big part of everything. So the spider dress that I showed you, and I just want to show you like really quickly how things like look in the past. These designs all get upgrades and updates. So whenever I see a new kind of piece of technology, like for my smoke dress, for my spider dress, for whichever dress, I start to re-engineer them, rework on them. So this was a spider dress in 2010. And also the smoke dress has many versions. The spider dress has 2, the smoke dress has 6 versions. So this was one that was was prior to that. So whenever I get a chance, I always kind of update these designs. So this was from, I believe, 2008, and that is kind of how that started. The last part is education. Working with children is really fun, especially because my dresses are based on animals, and animals work really well with children. So I do a lot of kind of things. This was in Vienna. This was not me. There was a teacher that was working out my designs using Lego Mindstorms, and working this out using like engineering and soldering and 3D printing is already like a thing. But doing that in Lego Mindstorms is like super awesome, I think. So I told them that I would show everybody. So the system is really working. What they did, sort of, they also used the proximity sensors of Lego. So I think that's pretty cool. And because I'm showing it to everybody, they also started to work out other dresses. So they also created my cocktail dress, and then they presented it back to this festival that I presented it in the beginning. It always happens in December, and it's called Robo Exotica. So that was really fun. So I want to end basically my talk with open source, so making and sharing with your community. The ways that you can do that, of course, GitHub, throw your code on there. Maker is a big community, a little bit bigger in America. Thingiverse for 3D models, Instructables. Hexter.io is really cool for anything hardware related. And OpenBCI, if you don't know that, if you're interested in brain signals and how the brain works, there's a whole community for that. You might not know about that one, but it's pretty cool. So how I try to do that is, and I need to definitely do it more, but you can find some of my projects on Instructables. And you can, for example, see the cocktail dress, but also this one. How to get fashionably struck by lightning, because I was busy with two friends of mine, architect, and they use really big Tesla coils, and that is how you make your own Faraday dress, so you can withstand the voltage of 2 times 500,000 volt. If you are interested in that, it's a pretty kinky one. And then also, when you're creating like an Instructables or anything like that, like make sure that you like integrate everything. So these are light up kitty ears, and basically I did that with Hexter, with Alex of Hexter. So you can see like all the components. You can download everything. The Gerber files are also on in this case. How you can get everything. Get somebody to like check it or like work it out. So you make sure that that you went through all the right steps, because it might be very clear for you, for yourself, sort of, But is it also clear for anybody else? So that's always a really important thing. And then, it's always fun to do like workshops with that. This was with children. We did another version using felt, and you can like print them really flat. I'm gonna put this online soon as well, and you can basically stitch them in using like little lily pad Arduino things. So there's like different levels that you can think of that. But basically my thing is, if you're making things, basically make cool stuff. Like learn from it yourself, and then also share it with the world for other people to learn from. So open source. And thank you so much.